because the math science is never. Bisa hindi
Oh, yes.
Mas
Sabi.
sabi. Yung sa hindi ko alam yung
Lemon.
Tapi hindi awal. English ka to dia. Hindi ka hindi na.
breathing. तो मैं एडमिट कर दूंगा आएगा तो मैं कर दूंगा I think we just defined force. Huh? We just started what is force. Did we discuss balance and unbalance?
Yeah.
Okay, so there are certain terms. Let us understand it with the help of some illustration. Let's say this body is pulled towards left by F1. This side by F2. So here F1 is equal to F2, right? Will the body move any side? Huh? No. Then body is subjected to balance force. Okay, and both the forces acting on equal and opposite directions are equal. Then we say the body is subjected to balanced forces, and there will be no, therefore, so under balanced forces, net force on the body is zero. On the body will be zero. Will be while the net force itself is zero, will there be any change of state of the body? No. Thus, there will be no change in state of motion of the body. There will be no change in the state of motion of the body. What does this mean? This means if the body was at rest, it will remain at rest. If it was moving, it will continue to move with the uniform velocity. No change in state of motion. This means net force on the body is zero. A body at rest will remain at rest. And a body in motion will remain in motion along straight line. Without any straight line with uniform velocity. No change in velocity. If the body was moving, it will have some velocity. And it will keep moving with functional velocity. Okay, this is the meaning of what is balance force. Okay, now let's explore unbalanced forces. What is unbalanced force? Same situation. If now there is some net force which is greater than zero. What happens here? When the net force is greater than zero. One of the forces greater. So what should happen then? In this case, the body will accelerate or retard in the direction of greater force, depending on its state of motion. Okay, I'll actually work at the things depending on all of its state of motion. You're writing while I'm still speaking, right? You wrote me. So you're picking up whatever I'm speaking, you're writing parallel. So what does it mean? The second and the last thing. So how many cases can be possible for the state of motion of the second case?
You move towards the right or towards left. If so, F2 is
Or
big.
it could be at rest. Three.
Can't-
Three phases. Initially, the body was at rest, let us say. Now the unbalanced force situation is created. It is not that always unbalanced forces are there. So initial state of motion, the body could be at rest, or that the body is at rest. Now, in this direction, the force was exerted. So there is a frictional force that will also act. So many things will work out. So right now you just write off. People both discussion have different types of force. So when will it retard? If it moves in, let's say initially the body was moving in this direction, then it will accelerate in this direction. If initially the body was moving here, then retardation will act in this direction, right? If it is at rest, then also it will accelerate in this direction. Three cases to that. Making sense? Making sense? Yeah. And resultant forces, whenever more than one forces are acting on a body, the sum total of all its forces is resultant force. Yeah. So you replace all those different forces by just one force. That is the net force. That is net force or resultant force is the same. Okay. Right. Now we'll discuss the laws of motion. Before discussing the laws of motion, let us discuss some types of forces. All forces act on a body. To change the state of motion of the body, the force has to be applied on the body. What are the different types of forces? There are two types of forces, contact forces and non-contact forces. So when the force has to be applied, what is it? Push, pull, kick. This is done by making contact with the body. So there are various categories of forces that act by making contact with the body. One of them is frictional force. Frictional force. Then you have normal reaction. You have tension. Then spring force. Forces of spring forces. You also have forces exchange among colliding bodies. Forces during collision. Like when you strike, it is the striker. When it goes in hits points, they are colliding with each other, right? So the forces exchange during collision. These are all contact forces. Then spring force. When you have a relaxed spring, no force is acting. But when you stretch a string, what happens? What do you feel? You feel inward pressure, inward force. So spring exerts force in the opposite direction. That is called restoring force. the spring force or restoring force against it. So any elastic body, okay, it tries to regain its original shape. So those are also contact forces. Then you have tension. Tension exists in, it exists in stretched string, stretched string. Now one is like rubber band or spring, which when you know, it will, the shape changes and then the restoring force brings back the shape. Then there are threads or rope. You hang anything like this tube light, it is hanging. So it is not like a spring or a rubber, it is just hanging. Right? But when I pull it up, the string will be loosened. Then there is no tension. So tension only appears in stress string. Okay. If this tension was not there, this thing cannot be supported again. Because how the net force is becoming zero? There is gravity acting on this, na? See what happens here. Let's say it was hanged with a thread, somewhere here. So if I bring it here, the thread is loose. So there is no tension in the thread. But now when I bring it down, bring it down, bring it down, let's say this was the length of the thread. Now it will hang, so now tension developed. So it is the tension which is holding it. Gravity is pulling it down, but now the tension in the rope is holding. That is also contact force. Then you have normal reaction. Now what is normal reaction? Look at this duster. No, this is not tied with any. Is it tied with any rope or string? No. If I drop here, what happens? It will be stopped here. It drops till here. Okay? It drops till here and then stops. That means there is something which is, making it its net force zero. Only then the state of motion will not change. So force has acted, no? That's why its state of motion has changed. Has gravity stopped acting here now? It is acting always. Then why it is not going down? There must be some force applied on it in the opposite direction. That must be equal to gravitational force. That force is normal reaction. So whenever two surfaces are in contact, right? There acts normal reaction. Okay. And what is the direction of that force? Like this. This normal reaction is acting on it in the upward direction. And weight is acting, gravitational force is acting in the downward direction. Okay. Now what is frictional force? Look here. If I apply force on this, I applied force, it started moving. Then what stopped it? Friction. Okay. There has to be some force now because if there is no friction here, it will keep moving. So to change its motion, there must be some other force acting because force is required to change the state of motion. Got it? So this is also, so friction acts when two surfaces in contact with each other are in relative motion. And it always opposes the motion. It acts in the direction opposite to motion. Yeah. So that is friction, that is also contact force. Okay. So all these are examples of contact. Then there are certain forces that act on a distance. There is no need to be in contact. What is the example?
Magnetic force.
Magnetic, gravitational, electrostatic. So these forces act over distance. So gravitational force, then you have magnetic force and electrostatic. So here the bodies may not be contact, right? Now what is the difference between gravitational, magnetic and electrostatic? One difference is gravitational is always attractive. There is no repulsion, right? Whereas magnetic force is attractive as well as repulsive. Same is true for electrostatic. So where gravitational force acts everywhere between bodies which has mass. Okay, any object which has mass, you know. So like these two objects also have mass. Why they are not attracted towards each other? We'll learn about it in the next chapter.
They don't have positive and negative.
No. So that is a different category of force. This also has positive and negative charge inside it. This also has positive and negative charge. But this is insulator. Net charge is zero. But if I then bring it near the then it will attract. So that is a different category of force. Okay. So the magnetic force acts between magnetic substance, like between two magnets. Like poles repel, unlike poles attract.
Okay.
Or between a magnet and a magnetic substance like iron and a magnet. This is between charged particles. So like charges repel, unlike charges attract. And when you increase the distance between the bodies, these forces, they are stronger when the distance is less. And when the distance is increased, it becomes weaker. Okay, this is also the proportion. Anyway, I just gave you the background. And now we will study some laws. Okay. How these forces are governed and how these forces are calculated. So that you'll understand once we study Newton's laws of motion. First is Newton's first law. I know. It states that a body at rest continues to remain at rest. A body, comma, a body in motion continues to remain in motion continues to remain in uniform motion in straight line unless it experiences or unless any external unbalanced force is applied on it or until an external unbalanced force is applied on it. Let me just see what is given in your volume. Is it similar? Okay, so that's similar, right? So why it is so? You should be curious to know why it is so. Why a body at rest remains at rest. A body is at rest remains at rest, understood. But why a body in motion continues to be in motion?
Stops at a point. Everybody stops.
That is subject to external force. What if the external force was not applied? Until the external force it stops because friction is always there. So what if, let's say, this surface was frictionless? Space. In space, you throw something. What happens to it? Endless travel. There's no friction. So there is an inherent property of the body which is called inertia. Okay. So it is due to inertia. That's why this is also called as law of inertia. Newton's first law is also called law of inertia. Okay. So we will have to understand what is inertia. So, what is your experience? When it is easy to change the state of any body, when it is lighter or when it is heavy? Right? So it is very easy to set this pen in motion by applying a very small effort. But if I have a heavy object, 100 kg, can I change its state of motion easily? No. So, a heavy object has higher inertia. A lighter object has lower inertia. What is inertia? It is the right on inertia. It is the inherent property. It is the inherent property of a body to resist any change in its state of motion. To resist any change in its state of motion. Full stop. Inertia of a body depends on its mass. Inertia of any body depends on its mass. Therefore, mass is the measure of inertia. Mass is the measure of inertia for any given body. Okay. Thus, lighter objects have small inertia, whereas heavier objects have large inertia. So whenever the term inertia comes, what should flash in your mind? Resistance to change. Okay. Resistance to change the state of motion. This long sentence is replaced by just one word, motion. Okay. So then this is apt. Therefore, Newton's first law is describing that because this is by observation. You observe it all the time. Yeah. So unless some external force is applied, the state of motion does not change. Now, so there are certain examples, right? To understand inertia in a better way. So let us say you have people standing inside bus. And the driver suddenly starts it. Suddenly starts the bus. What happens to them? Right now, bus is stationary, and he suddenly starts it. What happens? Okay, so people tend to lean backward, when it suddenly goes forward. Why is so? So there is a foot on the floor of the bus. They are standing on the floor of the bus. So there is friction between the floor of the bus and the foot. So the whole body is at rest. The body tries to remain at rest, whereas the foot moves forward. The upper body tries to remain wherever it was. That's why it moves ahead. Okay. Similarly, if there is a moving bus and suddenly the brakes are applied, so then what happens? The whole body is in motion. The floor of the bus comes into sudden rest, but the upper body was still moving. Now, tries to go in motion. Okay, so the previous situation was an example of inertia of rest. Inertia of rest. So they fall backward due to inertia of rest, right? And they fall forward due to inertia of motion. Okay? So these are the inertia of motion. So this comes into play during sudden acceleration. Sudden acceleration. Causes passengers to fall backwards. This is an example of inertia of rest. Then inertia of motion example. Sudden application of brakes. Due to inertia of rest. Upper part of the body. Sudden application of brakes. इसमें वो सब कितना भी लिख सकते हैं puts come to rest because of friction. Always. Passengers to fall forward due to inertia of motion. Of the upper part of the body. Okay. So these are some examples of right. Okay. So what did you learn in the first law? Concept of inertia, right? And also a concept of force was introduced. What do you learn in first law? There is something called as force, which is needed to change the state of motion. Just the qualitative definition of force came here. Something, but what is that force? How to measure it? That is given by the second law. Okay? First law only states force is required to change the state of motion. But how to measure force is given by second law. Right? So force is basically what? It is impact. What is force? Impact. Right. Now let's talk about impact. So what will this impact depend on? Let's say I gently throw this pen at you. Gently. So you will experience some impact. Same object, same mass. I throw at a greater speed. Will the hurt will be more? Impact will be more. Right? So impact depends on speed. Slowly and fast. What is the difference? Speed or velocity. So impact depends on, that is force depends on velocity. This is one thing. Right? Now I throw gently a lighter object to you. And I also throw a heavier object at the same speed. Which will damage more? Heavier one. Like let's say I'm sitting here and a plastic ball falls on my head. So what is the acceleration due to gravity? Let us say from the terrace, the ball to drop on my hand, my head, it takes 4 seconds, right? So every second, what is the speed achieved by ball? 10. Next second, 20, 30. So it will hit me with 40 meter per second. Okay. So instead of a ball, now I have a stone, right? If I drop the stone, now it is heavier. But speed gain will be same. Initially it was at rest. First second, 10, 20, 30, 40. Now when a stone hits me with the same speed, now the hurt is more, impact is more. Right? So therefore, this impact, which is force, also depends on mass. That means force depends on product of mass and velocity. Force depends on product of mass and velocity, and this is called momentum. It depends on both, right? So linear momentum P is defined as product of mass and velocity. Product of mass and velocity. That is V is equal to M into V. So this is a new physical quantity. Okay. What is the unit of linear momentum? Unit of mass multiplied by unit of velocity. It will be kg meter per second. Kg meter per second. Okay, that's now we are ready to study the second law of Newton. So what it states is mathematically states is directly proportional to rate of change of moment. So what it means is, let me explain here. Suppose this is a body, right, of mass m. Now when I apply a force on it, right? Let us say it was initially moving with u. After some time, it will start moving with v. When the force is applied, it will accelerate, isn't it? Force is applied, it will accelerate because velocity will increase. U से क्या हो गया? V. Because it experienced some acceleration in the direction of force. है ना? Voltage के direction of force लगा, it will accelerate. So what happened? Its momentum changed. So what is the rate of change? And let us say it took time t. In t time, its velocity changed from u to v, right? So what is the rate of change of momentum? So change in momentum is mv, mv minus mu. This is change in momentum. So rate of change will be this. The rate of change. So F is therefore proportional to this. Rate of change is how much time the momentum takes. Right? Time in which its initial velocity changes from u to v. Rate of change is this. In time t, mu to mv. Therefore, in unit time, that is rate. Rate is always unit time. Okay, so this is as per Newton's second law. So you remove proportionality before that. You can say m v minus u by d. What is v minus u by d? Acceleration. So therefore, F is proportional to and A. Right? So F is proportional to M. Now, that's the right idea. So when I remove the proportionality, I will have to put some constant. Because it is proportional, not equal. To make it equal, I have to introduce something. Right? So this is what it is. So where K is constant of proportionality. Now if I choose the unit of force in such a way that value of K becomes 1, right? If unit of force is chosen in such a way that K is equal to 1, then F will be equal to M. Okay, so what will be that unit of force? So let us say 1 unit of force is equal to K times What is unit of mass? kg meter per second square. Let's say 1 unit of force is equal to kg meter per second square. Right? Right. What unit I am choosing of force? kg meter per second square. Therefore, let's call this as equation 1. From equation 1, what do we get? kg meter per second square. So to k. What is unit of mass? That is also kg. Unit of acceleration is meter per second square. Therefore, k, what do you get? This one. Okay. So if I choose unit of force as this only, then k will become 1. So this is what is unit of force. 1 unit, and this is for Newton. So where 1 kg meter per second square is equal to 1 Newton. So when I choose the unit of force as Newton, that is when value of k becomes 1. Okay, because I know what is unit of mass and what is unit of acceleration. Clear? So this is nothing but mathematical derivation of Newton's second. Okay. So now read the statement of Newton's second law and how we derived it mathematically. Just read from the book. Read before example 1. Did anyone try to come online? I didn't realize. I didn't realize. So anyway. Understood? Absolutely clear? Okay. So Newton is SI unit. है ना? kg meter per second square. These are, so this is SI unit of force. What if I had to choose Celsius unit of force? Kilogram will become gram, meter will become centimeters. Okay, so that becomes gram centimeter per second square, and that is called as time. Okay, so just write down. So SI unit of force is what 1 Newton is equal to 1 kilogram meter per second square, which is equal to 1 gram, 1000 kilograms. So this is 10 raised to 5 gram centimeter per second square, or 10 raised to 5 gram. So this is the relation between dryness, the 1 gram centimeter per second square. There is CGS unit of force. Yeah. So this is the relation between SI unit and CGS unit. Right. So now we have just some questions and do these questions here. Do the example. Page number 3, example 1. Everybody has second volume. So do the example wherever you need my help. Let me know. That's good. Answered. You started doing homework.
Yes.
10 questions per day. That rule. Oh. 10 is minimum question. You're free to do maximum limit is decided by you. Okay, 10 is minimum question. In the other class, they did 40 questions. Some MCQ कर दिया. They came with lot of doubts. 30 questions in a day. Actually. That's it. One more law is remaining. First, you do the numericals. Don't see the solution. Without seeing the solution you will end up doing it faster. What is given? Have you done it or you need help? Where? Last part. Okay. Find the magnitude. So you got the force now. Now, if the force was applied for the duration of 5 seconds, right? So what is the final velocity? So what is velocity? You have the initial velocity with you. You can find the final velocity if you have acceleration. So what was the acceleration? You have force and you have mass of the object. Is F by M. Force acting is the same force is acting for now 7 seconds. Find the magnitude of the plane. Now, if the force was applied for duration 5 seconds, the acceleration to वही है ना? Whatever is the acceleration, it will be F by M. Then V is equal to U plus 80 is F by M. Right? See, what do you have? First part you calculated force. So your force How much you got force? Huh? 10 Newton. You got 10 Newton. Okay. That is mass into acceleration is equal to 10 Newton. So acceleration कितना आ जाएगा 10 by m. What is mass? 5 है ना? 2 meter per second square आ जाएगा. What is v? U plus 80. So u कितना है? What is u? 3 meter per second. ये कितना है 2. कितना आ गया? 40. यही है क्या? ठीक है. तुम्हें एक्चुअली ये फॉर्मूला हमारे पास है ना v is equal to u plus 80. तो ये कैसे निकलेगा? a is nothing but f by m. उससे है. वो भी उतना ही फोर्स लगा रहा है वो. खाली ड्यूरेशन चेंज कर. नेक्स्ट. अच्छा. वो v is equal to u plus f by m के फॉर्म में दिया था इसलिए तुम लोग कंफ्यूज. nothing but f by m is a. Health just a call away. Huh? Don't stress yourself. Any problem in example 2? No. Example 3?
Also,
So, okay. How are you finding this chapter?
By the formula, of course, we will find the mass for both.
Hmm.
And then we will add the mass and by the same formula, we will find the acceleration.
Excellent. So basically, in example 3, you have same force applied to 3 different masses, M1, M2, and M1 plus M2. That's all. Force is same, right? Only masses are different. Always read the questions 2 times slowly. Sometimes what happens in one reading, you don't understand the whole, you don't grasp it completely. So break it down, read it slowly. Wait after comma, full stop, stress thinking. Then it unfolds. There is only one more law in your book, Newton's third law. But in volume, we have law of conservation of momentum also. Okay? So it used to be in old syllabus. But this year in your book, it is not there. But there are numerical which uses this concept. Okay? So they have removed the portion, but they have kept the numerical. So I'll teach you that as well. So let me know once you're done doing the numerical. In this chapter so far only one formula. Yes. Or is equal to MV. That's it. These two things you have used so far in this chapter. Okay. Done? Now, anybody needs any explanation? Huh? Simple examples?
M is mass or M is momentum?
Mass. Momentum is mass into V. So what is, okay, MU is initial momentum. And this is final momentum, and V.
So P is momentum.
V is momentum, linear momentum. Linear. That's the
But
motion.
you said so.
What is that? So what is force? Rate of change of momentum, no? What is rate of change? So change in momentum is Pf minus Pi is equal to Mv minus Mu. What is change in momentum? This is change in momentum, delta P. What is rate of change of momentum? It is delta P by delta T. What is the time interval? V minus mu. This is the rate of change, dP by dt. Okay, this is the rate of change. This is force. This. Because K is 1. We have chosen the unit of force as that K is 1. Understood? This is mass. Oh, no. M for momentum, no, not like that. It is not M, A for apple, B for baby. It is not M for momentum. This is mass. So we have defined momentum as a different quantity. Linear momentum, which is P. Okay. Right here. Am I missing anything? Ask questions like this because I will not realize what questions you have. Therefore, let us discuss some examples of second law of motion. What are some examples of second law of motion? So, force signifies impact, right? The examples of second law of motion. Like we discussed inertia of rest, inertia of motion. When will you hurt yourself more? When you fall directly on a hard floor or with some cushion, with some mattress? Directly on the hard floor. Why? Let's say I'm jumping. Let's say I was standing and I jumped on the hard floor. And then I jumped on some cushion floor. When the impact of the hard will be more. Hard floor directly. So why so? No. So this is MV minus MU divided by T. So when will F be large? When T is small. Right? So T is, so it is rate of change of momentum. So initially I will have some initial momentum. Initially, I will have initial momentum. Then finally, this becomes zero because final velocity on landing will be zero. So from some momentum, let us say if I am 70 kgs and I drop, if this is like 1 second it took me. So I fell with 700 kg meter per second. How much did I fell with? What was my momentum? 700 kg meter per second. Initial momentum. And then it becomes zero suddenly. What was the time? Let us say I took 0.1 of the second to stop. So from 700, my momentum is becoming zero. In how much time? 0.1 second. So what is the force I have? What is the force? This is 7,000 kg meter per second square. Force that my heel gets is 7,000 Newton. Okay. So is there any way I can increase this duration? Because my momentum suddenly changed within 0.1 second, being a hard surface. Now I put such thick foam. Okay. So now I will not suddenly become zero. I will become zero after say 1 second. It took me 1 second. The foam will get depressed. Okay. It took me 1 second. Now what is the force? 7 when it is 1. So suddenly how much it is reduced? 10 times. So impact will be much lesser when I increase the time, which means rate of change of momentum is reduced now. Momentum is changing at a slower rate. Slowly it is changing now. So impact not only is governed by the change of momentum, but how fast or how slow the momentum is changing. That is what governs impact. Okay, another example I will give you. So when you're playing cricket, right? If a ball is coming at you, so if you're not an experienced player, you'll try to grab the ball just like that, and you'll hurt your hands. But an experienced fielder will pull his hands back. So in the first case, ball was suddenly stopping. Momentum was changing in a very short duration. So it may hurt your hands, right? But now when you catch the ball and pull your hands back and then slowly stop, you increase the time. So the impact is much less. Understood? This is the application of second law of motion. Okay. All right. Let's understand third law of motion. Okay. So impact is a function of rate of change of momentum, not just the change of momentum. Okay. The rate at which it is changing. What is third law of motion? Third law of motion is very simple. Write down the statement. It states that every action has an equal and opposite reaction. She smiled while stating the law. So simple. Yeah. It is one of the simplest law and most misunderstood law. So then what happens? Does action cancel reaction? What is action and reaction? Action is force. Reaction is also a force. Right? Right now, full stop के बाद में. Here action and reactions are forces acting on action and reaction are forces acting on different bodies. Forces acting on different bodies. Now, this is not part of the law. Law is just one statement. Now we are describing further. Okay? Here, action and reaction are forces acting on different bodies. Hence, तुम क्या बोल रही है? Action is equal to reaction, इसलिए action cancel reaction. Is action cancelling reaction? They are acting on different bodies. Therefore, both leave their. So is it cancelled? But in general day-to-day language, every action is equal and opposite reaction. मतलब it cancelled. I did something good, you did something good, or if I did bad, you did bad, nullified. It's not.
Impact is still.
Huh?
Impact is still me.
Practice.
Impact is still me.
Impact is there. So here, in this case, what did I write? Action and reaction act on different bodies. Therefore, both leave their impact on each other. On each other. Okay? Both leave their impact on each other. So what is the example? But the impact may be different on different bodies. Right? Like for example, if I punch on this wall, will I get hurt? Yes. Will the wall get hurt? It is not getting hurt, but was the force similar? Same force? Action is equal to reaction. Force is same. The reaction by wall is sufficient to hurt my fingers. But whatever force I applied on the wall, same force, is not able to do anything to the wall. Force applied is same. Let us say I applied 100 Newton force. Wall also will apply 100 Newton force. I'll get hurt. Nothing happens to me. Okay? So the impact is different. So what decides the impact? Huh?
Yes.
It's the mass of the body. It's the mass of the body. Okay? It produces less acceleration. So, the most frequent application of Newton's third law of motion is, let us say you had two different bodies, right, of mass m1 and m2. This was moving with u1 and this was moving with u2. So if u1 was greater than u2, then it will collide, right? But during collision, this body, second body experiences force in this direction. Force on the second body due to first body. And this body experiences force in this direction. Force on first body due to second body. Okay? So these forces are equal in magnitude. F12 is equal to minus F2. This is how it is. These are vectors. The vector is denoted with an arrow. This is mathematical form of Newton's third law, right? Now, which body will move fast and which body will move slow after collision? Initially, first body was faster than second body. After collision, what will happen? Its motion was here. Its motion was left to right. And this motion is also left to right. But now first body is experiencing reaction opposite to its motion. So this will slow down. Whereas this body will move faster now. Okay? Both will continue to move in the same direction. But now This will be V1 and this will be V2 with V2 greater than V1. Isn't it? Because this experiences retardation, whereas this experiences acceleration. So the impact is different. One slows down, the other moves fast. And same force is exchange. Minus sign because they are in opposite direction. Okay, समझ आया? This is what it is. So, what did you write? Action and reaction are
Action and reaction are forces acting on different bodies. Therefore, both feel their impact on each other.
So in bracket, right? That is action and reaction forces do not cancel each other. Action and reaction forces do not cancel each other. Let's look at this examples of third law. Remind me. We will discuss the examples of third law in the next class. Did I bring my book? No.
Sunday for a by look how to swap. One half is good. One half is for the by I was thinking or English of the yeah, so the big answer.